Professor A.V.N. Reddy Garu, Dean Faculty of Sciences, Professor Pushpa Chakrapani Garu, and all faculty members and dear students, a very good morning to one. As we are aware, today we are celebrating National Mathematics Day on the occasion of birth anniversary of great mathematician Sri Srinivas Ramanujan. The Government of India has declared 22nd December as National Mathematics Day and the year 2012 as National Mathematics Year. It was introduced by the Prime Minister Dr. Manmohan Singh on 26th December 2011 at Madras University to mark the 125th birth anniversary of Indian mathematician Srinivas Ramanujan. The celebrations aim at spreading awareness about the importance of mathematics and the contributions made by Srinivas Ramanujan in the field of mathematics. Firstly, I would like to wish you all a very happy National Mathematics Day. On this occasion, the Department of Mathematics, Dr. B.R. Ambedkar Open University, is organizing a lecture program on data modeling and visualization. I extend a warm welcome to all the attendees in this program. Now, I welcome our today's speaker of today's program, Professor V. Haragopal Garu, Professor of Statistics, retired professor from Osmania University, to come on to the dais. I request. Thank you for accepting our invitation, sir. On this occasion, I would like to speak few words about the great mathematician Srinivas Ramanujan. Srinivas Ramanujan was born on 22nd December 1887 at Kumbakonam in Tamil Nadu state. His parents were Kupuswam Srinivas Iyer and Komalatammal. He had spent his childhood days in great difficulty and poverty. He used to borrow books and read books from friends in school. When he was young, he took up the job of clerk to meet the economic needs of the family. During his leisure time, he used to solve mathematics questions and work on various types of theorems. By the age of 11, Ramanujan developed his own sophisticated theorems to master trigonometry. By the age of 17, the young mathematical genius Srinivas Ramanujan had received several awards and merit certificates. In 1911, Ramanujan published the first of his paper in the Journal of the Indian Mathematical Society. In 1916, he was awarded his BA degree from Cambridge University. His work and intellect were recognized by British mathematicians too. He was elected to the London Mathematical Society in 1917, also elected to the Royal Society of London in 1918. He was the second Indian to be elected to the Royal Society and one of the youngest fellows elected in the history of this society. Also, in 1918, he became the first Indian to be elected to the Fellow of Trinity College, Cambridge. He compiled around 4,000 research results, which involved theorems, equations, and identities in number theory and algebra. He published several papers of great mathematical significance with his mentor, Professor Hardy, during his stay at Cambridge University. In 1919, Srinivas Ramanujan became very ill, which compelled him to return to India from Cambridge University, London. Professor Hardy met Srinivas Ramanujan in the hospital and stated that 1729 seemed to be a very dull number. But in contrary, Ramanujan said that it is a very interesting number. 1729 is the smallest number which can be written in the form of the sum of cubes of two numbers in two ways. That is, 1729 is equal to 1 cube plus 12 cube is equal to 9 cube plus 10 cube. Since then, 1729 is called the Ramanujan's number. The genius mathematician Srinivasa Ramanujan died on 26 April 1920 at the young age of 32 years. His contributions in the field of mathematics has been immense and will be remembered forever. And tribute to the great mathematician Srinivasa Ramanujan. Really, I feel blessed and honored for speaking about the world's greatest Indian mathematician, Sri Srinivasa Ramanujan. Now, I would like to introduce our speaker of today's program. It is very pleasure for me to introduce our speaker today. Professor V.V. Haragopal Garu is retired professor from Department of Statistics, Usmania University, Hyderabad. He served as head Department of Statistics and chairman Board of Studies in Statistics, Usmania University, Hyderabad. He also worked as director at Center for Quantitative Methods and also director at iGen Algo Private Limited, Hyderabad. He has 37 years of teaching experience in UG and PG. He served for 7 MPhil and 30 PhD candidates. He supervised for 7 MPhil and 30 PhD candidates. He published 165 research papers in national and international journals. He worked as a member in editorial board of journals. He worked as editor for course material in OU distance education as well as Ambedkar Open University, Hyderabad. He delivered invited talks and resource persons to many state and central universities as well as research institutions and also conferences. He involved in various surveys and data analysis undertaken like habitation survey conducted by Government of Andhra Pradesh, BC survey by IST Hyderabad, poverty estimation of Kuppam constituency Andhra Pradesh, poll analysis of Karnataka state, MSET results analysis, intermediate marks weightage in MSET Government of Andhra Pradesh. Presently he is IRB member at Axis Pharma and consultant EPTRA, Hyderabad. Now I request Professor Haragopal Garu to give the lecture on data modeling and visualization. Thank you. Thank you, Yamanda.
Thank you, madam. So I am thankful to Dr. Vijay Kumar and Madam Sridevi and the Vice Chancellor of Ambedkar Open University. And then I see a lot of youngsters and who are eagerly to know about my lecture. See, it is not directly, my lecture is not directly mathematics, but it is the visualization techniques because most of the youngsters are nowadays into data sciences and a lot of scope and a lot of scope and as well as a lot of job potential is being seen. So under that particular pretext, I can say that here there is no difference between as such. Maths involves a lot of derivations and then a lot of formulas and all, but statistics uses those equations and formulas and then evaluates the data to have a real picture of the data. So ultimately, Ramanujan has invented certain things and those are being used in various aspects of physics, mathematics, and as well as the other fields of statistics, particularly in terms of social statistics is one of the very much interested subject which people will do, right? So under that particular context, mine is exclusively a data analytics approach. So how does data is being analyzed? See, you see a lot of tons of data and then in many facets, you can as well see these data. Like you can take census data, you can take any small sample, like in venture capitals, or marketing data, or social data, even your Twitter data, or even your Facebook data. So Facebook consists of both pictures and as well as text data. So how do you handle this type of a situation, right? So I'm really not into going into the. Recently, I have changed my analytics aspect, not exclusively data, but data related to text, right? So I have analyzed almost 77 episodes of Honorable Prime Minister's Narendra Modi's speeches. And then what is that actually he's talking? So what are the things he's really talking? What is his man is saying? And I mean, a lot of scope is there in the textual mining. So one can have a lot of this thing. Like we have also evaluated Chaganti Koteshwara's Pravachanams. And what is that actually he's talking? And also we have some political speeches. So a particular constituency is there. So all leaders go and then deliver lectures. So what is the stress given by each one of these political leaders? So this is actually the latest thing which is going on. And also I worked for 4 years and I am also visiting now BITS Pilani, Hyderabad. There also we have done a lot of work on textual data analytics. And the latest which we have done it is the music analytics. So you know music analytics. What is music analytics? The data which you see in music is actually a wave, right? So that wave has to be converted into data and then say that here, what sort of a this thing is? Is it actually a I mean instruments which are used English music, or is it actually a other types of music is being seen? So under that particular context, what is that actually data? Can I ask, I mean, what are the various data types you have seen it in your lifetime? Or most of you are also studying statistics, computer science and all. Can anyone say what are the various data types you have? No. So this is actually basic backbone of data analytics. So you have actually various data, like height, if I say, it is not actually, I mean, you call it as data, but it is actually a measurement data, right? So all measurement data are being classified as variables. That you have seen it in your statistics second year, this thing, right? Then you have attributes. What are attributes? Attributes is gender is attribute, right? And which area you belong. So that is whether it is actually an urban area or a rural area. So these are all attributes. And then also I say that here, do you like biryani in Paradise Hotel, right? So I can't make it as actually a yes no, but how best the guy who's selling biryani, is it actually very good or very bad? So then I just go for a strong, yeah, I say that, yeah, very good, fantastic, then good, neutral, not good. So this type of data is called as what actually ordinal data, right? So gender is male and female, which is called as nominal data. And then when you say that a very good to bad, right? It is called as ordinal data. The height, weight, etc., etc. It is called as what actually it is measurement data, right? So why do you want to identify that here which data type you are using it? Because this helps a proper guidance to your conclusion, to make a conclusion of the project you are taking or data analytics which you are taking. Suppose if I say that here, if I just take it gender, and if I calculate mean and variance, will it be meaningful? Someone said no. Why? Why? Can you tell me the reason for this? Gender, can I calculate the average? Suppose if I just code the gender as 1, 2, 1 is female, 2 is male. I have a set of data, some 20, 30 people are there. So 30 people are there. I have 30, 1, 2, 1, 2, 1, 2, or 1, 1, 1, 2, 2, 2, 2, like that. Right? So can you tell me what will be the average of this? Can you tell me the average of this?
Between
1 and 2. Correct. Correct. So 1.5. Let us assume that here, all the 30, 1, 2, 1, 2, it turns out to be 1.5. Will it be meaningful? No. It's meaningless. So therefore, if you identify the data type, then this data type has to be a meaningful conclusion of the data collected should be there. So this gender being an attribute, and it is a nominal data. Hence, average, variance, etc., should not be calculated. Then you can ask there, yeah, what is that? You can as well do this here. So you can as well collate and then take the frequency table of this 1, 2, 1, 2, 1, 2. Right? So then you get so many males and so many females and their percentages in your sample. The next thing is that here, so mean and variance is ruled out. You have to calculate only the median and mode. You know what is median? Median is the mid value of this particular data collected. What is mode? Mode is the highest frequency, how repeated value. How many times a particular number is being repeated. So these can be calculated, but not the mean and variance. So for this sort of a justification, before going for any analysis, we just go for what is known as the visualizations. Because suppose if you are working in a software company and then your boss doesn't know any statistics out of it, only you are the boss, you do the analytics and he should be understood of your analysis. So under that particular context, we just, taking like Ramanujan's equations or Madam said 1729. So 1729 is a number, but boss doesn't know what is 10 cube and all. Say all bosses are CEOs are all MBAs or management aspects. They are not that thorough in the mathematics aspect. Right? You are the key for the boss. So you have to justify your analytics. So if you just directly go and then say that here, if you explain that here you have done t-test, f-test, chi-square test, or ANOVA, or all blah, 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 if you say, you may not understand really. So then for that sort of a thing, what we do is normally first we go for a visualizations. Whether a females are dominant in my data set or males are dominant. So then under that particular context, you just go for what? Visualizations. So you construct a pie diagram, right? Or you construct a histogram, right? Or you can construct any other visualizations, which I'm going to take it here. So for that reason, we just go for a visualization because these are helpful to the people who doesn't know anything of either mathematics or statistics. So this will help a particular person to understand, oh, this is a male-dominated survey or a female-dominated survey. Ultimately, that is my conclusion of the attribute which I have collected. Right? So this is what actually we have. So next comes, what is it actually? I have the measurement data. So measurement data is what actually the measurement data is height, weight, cholesterol level, blood pressure levels, etc. So any scale measurement is called as measurement data. So after dealing with measurement data, you just go for statistics deals with two aspects, continuous data and discrete data. You must have studied in here random variable definition and all, right? So continuous and discrete. What is the difference between these two? Any student? What is the difference between continuous data and discrete data? Can you give me one example? Simple example. So, see, in your books, textbooks, or in your notes, it is there that here the number of suicides taken place during a year is discrete. But I don't understand that. Simple definition, not textbook definition. Your hands-on definition. Continuous random variable or discrete random variable. So measurement data consists of this here. See, it is very simple. See, I tell my students that here, what is discrete? Suppose if I just take it, the lower bound is 0 and upper bound is 1, right? The number of suicides taken place during 1 year. So every month you don't find any suicides, air accidents. So any discrete data happens with some gap, right? So in one month, in a particular locality, there are only two suicides. Next month, there are no suicides. So then 2 to 0. This is a gap. So that the data which you are collecting is the discrete data. While continuous data is what actually there is no gap at all. Continuously it happens. That's what age is a continuous data. Height is a continuous data. Weight is a continuous data. So this distinction, if you don't do it, definitely you are going to have a conclusion of your experiment turns out to be very bad. So that means Ramarjam thought that here simplification is the key. Simplification is the key for what? For complexities. So you have many complexities in your data. You want to simplify that into this particular various data types and then handle with the data. So this is the ultimate. That's what actually data sciences are, or ML modeling, AI modeling. All these things comes under this, but the backbone of this analytics is the data type you identify. So then comes univariate data. You have bivariate data, you have multivariate data. What is this univariate data? Can anyone tell? You are doing it all univariate and bivariate, not beyond. Your normal is bivariate. Normal distribution is bivariate, right? Exponential is a single variate. What is this univariate? Like, for example, see, that's what actually I say that here, whenever you study theory, you just see immediately the application of that or have a hands-on. You yourself collect data, some 10 observations, and then analyze that here. So then you'll understand really what I am studying. I just always say that here, application is the key for your performance in the studies, right? So what is univariate? If I say that here for all these people, if I just take it height, so I have around 25 heights. So it's a univariate data, right? If I take height and weight, it's a bivariate data, right? So if I take it height, weight, cholesterol level, and blood pressure level, and various aspects, if I take it, that will be multivariate. On each individual, I have multiple measurements. If it is a single measurement, it is univariate. If it height and weight, it is bivariate. If it is multivariate, you have multiple measurements on that. So this is the other aspect, right? So like, for example, if you say that here, you just go to any water samples, you take it, or your air pollution. So it has got zinc, carbon dioxide, etc., etc. So the data which you are collecting there is not a univariate or a bivariate. It is actually a multivariate aspect. So how best I can also analyze this and come to a conclusion? So for that, basically, I see that here whether the data is linear or non-linear. You know what is linear? Linear is actually a straight line. Non-linear is, it could be a wave form, or it could be a parabolic aspect, right? Or it is approaching almost the x-axis. So that means all observations which you have taken is nearing zero. So this type of a situation you want to study, then you have to go for the visualizations. Yeah. So I will be talking about that. Desktop launch. So this is what actually exploratory data analysis and data visualization. Yeah, next. Yeah, so this is our exploratory data analysis. Visualization is one variable. Just now I told you height is one variable. And the two variables is height and weight, right? Then more than two variables is height, weight, and cholesterol level and BP level, etc. So other types of data and dimension reduction. So given a set of data, how do you reduce the? So the mathematics you have studied, right? Right from your intermediate days or BSc first BA or BSc first year onwards. How do you reduce the dimension of the data? Huge data is there with you. It's a big data. How do you reduce that into? Huh? Grouping. How do you group it? No, it is like this. I have a 5 by 5 matrix. I want to reduce this 5 by 5 matrix into a 5 by 1 vector. How do I reduce? That is called as data reduction. How do you do that? You have studied in maths, particularly in linear algebra. You have studied, right, linear algebra? Right? How do you reduce? Studied eigenvalues, eigenvectors? Right? So that's what actually you do. You get a vector. 5 by 5, 1, 5 by 5 matrix. You can as well reduce that into a 5 by 1 vector. Right? So all the properties of this 5 by 5 are embedded in this 5 by 1 vector. Right? That's what actually happens when you have a smartphone. When you click a photograph, so will it go as a photograph into your mind? This thing? No, it goes as a Fourier transform. Right? So Fourier transform is nothing but a particular it converts into a matrix. Then it reduces. And then it gives you only a one vector. So whenever you want to access that particular photo, so you are accessing that particular vector into an image. So this is called as the pattern recognition. So these are the various aspects with which you can as well get the reconstruction done. So for that, you just go for a dimension reduction. So what is the biggest dimension? It is a 5 rows by 5 columns, which is converted into a 5 by 1 vector. 5 by 5 is what actually? It is so many observations are there. Each row has got 5 observations and 5 rows and 5 columns. Right? 25 observations are. 25 observations are being converted into, reduced into 5 observations. And it is representative of this 5 by 1 vector is representative of 5 by 5. This thing. So this is mostly, it is also called as singular value decomposition. So there are many ways of doing this particular aspect. And this is what actually we can as well do. Right? So just for the degree, don't do that. Take some data, really practice yourself, then you will have very good knowledge of the technique or the subject. Just simply, if I just by heart and then write it and then get a degree, but if you just go and then ask, if someone puts a question, you may not be really in a position to answer it. Don't do that. See, you should be one. See, nowadays the world has changed. Everyone wants hands-on. So degrees, many people have degree. But in what way you are unique from your other friends? So that uniqueness has to be built up with you. Right? So that is what actually we have. So, I mean, whenever you have data, so much of data, that can be visualized into a particular aspect. Like, for example, I have around 50 ages. So let us assume that here there are 50 people here. I have 2 categories, male and female. And I have ages, right? I want to have an average age. I can ask, because this is actually a continuous data, I can do variation in the age. Average in the age. I can get it. But what is the median age? Right? After getting the median age is what actually middle value of this male and female. How differing in this group the median age of male and female? Right? So then how do I show it? Okay, median age is so much, I'll say. But I want to know that here, how many are above median age, how many are below median age? So this sort of a questions can be answered through these visualizations. And that the question which I put it and then I am answering the same question is that we called as stem and leaf. Right? So how many are above median? How many are below median? What is the variation? So stem is this, I mean bar, and then leaf is actually a variation above and below. Right? So this can be obtained for male and as well as female. So this type of a visualizations we do. Next. So that's what actually whatever I've just now said that here. So symmetric distributions, normal, and then skewed. So what do you mean by skewedness? In normal, skewed distribution. What are skewed distributions? You study skewed distributions also.
Negative of the given.
Huh?
Negative of the given.
What is negative of given?
That is change in the, as you said.
No. When do you say the data collected is normal? It should be a bell-shaped curve, right? It's a visualization, right? So for this distribution, mean equals to median equals to mode. So that is the inflection point, right? So the number of happenings in negative side and positive side are equal, right? So this is actually a skewed distribution. I mean, it is asymmetric. It is not asymmetric, it is symmetric distribution. So because every property it undergoes. Suppose if I take it exponential, what is exponential? Theta e power minus theta x. That is your density, right? Theta is the parameter, x is the random variable, right? If I draw the data, see visualizations, I'm explaining. Visualizations are helpful to identify whether the data collected is uniform, symmetric, or asymmetric. So if I say that here, it is not a bell-shaped curve, but it is actually a protrude, I mean, it is gone to the right-hand side or left-hand side, more tail, then definitely it is not actually asymmetric. It is a skewed distribution, right? When it is skewed, so then definitely it is not normal. So how do I bring it to normal, this skewed distribution? You people are not studying statistics. How do you convert non-normal data to normal data? So non-normal data to non-normal data to normal data. Non-normal means what actually? This tail is very big and then it has gone this side. So definitely this side, all are not equal to the right-hand side. Left-hand side values are not equal to the right-hand side value. So then how do you convert it? So you have a standard normal, z equals to x minus mu by sigma. It's a standard normal, right? Right? X is the original observation. Mu is the mean of this original observation. Sigma is the standard deviation of this particular x. And then you say that, yeah, this is what actually happens under this particular context. So now x is not the value, but z is the value. So now you intend doing plotting that particular aspect. So then you say that, yeah, z is normal, not x is normal. So that is how you do this. So these are the various aspects you can as well study under visualizations. Yeah, next. Yeah, so this is actually a, right? So here, this is called as what actually, it is actually called as a pie diagram. So pi is what actually, it is once again mathematics, 360 degrees circle, right? So, and then each one of them is one particular part. So different, this thing. So each one's percentage, you can take it here. So like that. So this is actually one, this thing, so that we can as well do that. So this can be helpful in most of the pole analysis. In most of the pole analysis, you can say that here, which party is more poled, which is dominant, which are not dominant. So that sort of a thing you can as well do that here, right? Next. So this is a goal. Goal is that actually you want to see the data, how best we can as well get the data which is not model free. So I'm not suggesting that it is only a circle, I said that's all. But I'm not fixing a model to that particular data. So model validation has to be done. So that model validation is being done by, consolidating this particular data. Like rough data, if you just take it, the random data, if you just take it, you can construct a cross tabulation. Like how many of the male and female are belonging to urban and rural area. So now this is what actually I got it. I got a 2x2 table constructed. And then I want to know that area is one attribute, gender is another attribute. Whether these area and gender, are they different significantly? So you go for a chi-square test. So here, no continuous data. It is only a discrete attribute data. So that type of a situation we can as well do under these particular conditions of the exploratory data analysis. Next. So that's what actually I said that here. Sample statistics of data X, mean is this, summation Xi by N. Then most common value in X. Then median is actually, you just go for a mid value, right? So then you can as well go for quartiles, percentiles, and then et cetera, et cetera. You can as well do that here. You can calculate interquartile range, etc. So this is what actually I'm just talking about. This is negatively skewed. See here, mean and standard deviation is not falling at the same point, right? So this is the skewed distribution. This is positive skew. So positive skew, tail area is high, and then negative tail area is here. So this is what actually we have, call it as actually a skewed data which you have collected. So how do you know that this is skewed data? You have to plot it. When you plot it, definitely you know that this is the line. So this is not. If it is a normal, exactly it will be the middle inflection point will be mean, median, and mode. It is the same. So that is how you do the aspect here. Next. So slowly we are going to the visualizations. So the first one is the center variability, skewness, modality, and outliers of strange patterns. Bin means what actually from here to here, there is the bin. Right. So this is what actually means. So this is actually a diastolic blood pressure. So this is on x-axis, and then the frequency. How many are there in 20, 40, and 140, etc. So this is how you do. So this is not normal. You just take the midpoint here, midpoint here, and then join. This is right. So this is not actually a normal, abnormalities. So here also, this is positively skewed. This is also positively skewed. So that is how you do the normalizations. Next. So for small data sets, histograms can be misleading. So when do you use a histogram? For bigger data, histograms can be used. So then what is that actually you have to use? For small data, you just go for a bar diagrams. Right? So this, most of the people doesn't know. So simply you say construct histograms for small data or big data, right? So this is how the, you have this, this is looking normal, but it is not. So this is extending. So the same way, so this is the various ways of representing your data in visualizations. Next. So this is smoothed histograms. Density estimates are there, right? So these are the density estimates. So this is what actually, this is how you do the Gaussian aspect. So that is z equals to x minus mu aspect. You do the this thing. So this is actually a bimodal, bivariate normal. So this is one normal and this is another normal. So that is how you do the visualizations for the data of two variables. Next. So bandwidth choice is an art. Usually want to try several. So that is, this is density, naturally. And then this is the, see here, from here to here, it is changing, right? And then the third one is actually more this thing here. So this has got more humps. So that has been brought into normality. So how do you do that here? Standard normal, right? Next. So this is what actually I was just talking, box plots are stem and leaf. So this is the median aspect and an above median, and these four dots are actually outliers, right? So they are not within the range of the original data, right? These outliers you can as well, so above this 110, you can as well remove those points here. Outliers are also identified. This is the median, above median is this, below median. Above median is less number of people are there. Below median, more are there. So this is also outliers in the below aspect. So this is called as the stem and leaf and the box plot. And this can be used for what sort of a data? You can as well have a continuous, age is continuous data. Then male, exclusively male, what is the median age? So male, this is the age of this thing. And this is the x-axis is the male. So for male, this is the stem and leaf. For female also you can jointly you can have. Or exclusively only a male or female you can. So this is called as the stem and leaf or box plot. Yeah, next. So this is another one. So whether when your variable is time, right? Like the temperature for the past 1 month, you want to draw. So how do I draw? So how this thing, is it linearly going upwards, or there is actually some sort of a pattern, increasing, decreasing, and etc. haphazardly, right? So for that reason, you just go for what is known as the time series data. So what is time series? How do you define time series? Y equals to ft. So this ft, so the time series is actually a function of the time. Right? So this function consists of 4 components. What is that? Trend, TSCI, trend, seasonal, circular, and irregular. So these are the 4 components consists of the function of ft, y equals to ft. So that is how you do these things, and then you can as well notice the peaks, etc. there. Right? Next. So this is actually, see here, from here to here, this is the gap. So this is actually a discrete distance. And it is not equally distributed. The distance, the gap is not equally distributed. It is as in here it is the same distance is not seen. So this type of a data is called as what actually it is called as a discrete time series data. Right. Next. So this is better health, etc. Yeah, next. So would extend smooth weight growth plot, etc. So how the growth plot is being in age, as age advances, how the nutrition levels are being seen in the child is being taken. Next. Yeah. So this is also, conclusion, how do you do that here? So kids weighed in clothes, some are gone, etc. The weights will be changing it. So even that has to be taken into consideration. Yes, next. So this is another spatial data. So in spatial data, what is actually the geographic component? Like for example, nowadays everyone using Google Maps, right? So that type of a data is called as actually a spatial data. So what is the distance? So everyone nowadays are like in US, so even Indians are doing it that at what time my expected time of arrival. So at what time I should start, etc. So this is all what actually it's a evaluated data. So that is being seen. So whenever you say that here, if I want to travel from this point to this point, what is the time taken? And this is actually a scatter plot. And then it may not, even you can see that here, whether the ETA given by the this thing is being correctly done or not. So here, no data is being seen, but only a scatter plot is being seen. So if you see that here from here to here, the travel is a straight line travel. But here, if you just take it here, the others are depending upon your starting point to the distance. Suppose if you say you start at this particular point, and then you go to this particular point, it is a linear travel through the through your GPRS. Yeah, next. So this is another map. So where you can as well say that, numerical values are called chloropleth maps. So this is all, so red, so they are all having similarities in some aspects. So that is being studied here. Next. So this is two continuous variables. So this is one continuous variable, this is another continuous variable. So leaving these away, so the data is actually linearly related. So when you say linearly related, what will be the equation? What will be the equation? If the data is linearly representing a straight line, what will be your equation? Linear only. But what is the equation? Mathematical equation. Today is Ramanujan's birthday, right? Yes?
X plus B plus C.
Yeah. So y equals to a plus bx. Yeah. What is y? What is y? What is x? What is a? What is b? Y is a dependent variable, right? Y is a dependent variable. Y should be a quantitative variable. It's a measurement variable. A is actually constant. You say you are a mathematics student. It's an intercept. A is an intercept. A is an intercept. What is B? What is B? Huh? Come on. So you could be wrong. B is slope. B is slope. B is slope. Then X.
A by B would be the slope.
Which one?
Y is X plus B.
Huh.
Okay, sorry.
A plus Bx or Ax plus B? So B is actually your constant, that is intercept. A will be this thing, right? So X is what?
Independent.
Independent variable. So this is how your data represents. See here, these visualizations are very useful whether you are in a doubt whether my data is representing a linearity or a non-linearity. If I consider this, see here, if we just take it these variables, so this might be a non-linear aspect, scatter. So hence this turns out to be a linear aspect. So that is how you do the aspect of this. So that is my ultimate goal of identifying my data, how data behaves, right? So y and x should be measurement. In y equals to a plus bx, y and x should be measurement data. Age, income, right? Income is dependent on the age. So y is your income, x is your age. As age advances, your income also increases. It is linearly related. For that sort of a thing, you can as well go for a regression approach. It is called as a regression approach. So you formulate two normal equations by the method of least squares. So that is once again maths. Differentiate with respect to A, you get one equation. Differentiate with respect to B, you get another equation. Solve these two equations into unknowns, you get A and B evaluated. So you have to estimate A and B in the presence of Y and X. So that is how you do the aspect. Next. Same way. So just now, whatever I said, the same thing is being told. Right. Next. Yeah, this is scatter plot. So scatter plot is what actually? It is not random. It is not following any type. Right. So where do you use scatter plot? In statistics? Where do you use correlation? Correlation, Spearman's, or you say that here it is Karl Pearson's, right? So there you just do the scatter plot. So whether the data is random or it is following a particular turn, so etc., you can as well do that. So that is what actually does other aspect. Next. So this is actually a linear relationship. If you just go this way, it is a positive, and this way it is negative aspect. Next. So this is a curvilinear aspect. This is a curvilinear aspect. Yeah, next. Next. Yeah. So this is actually a band. This is a band, it is happening, a fixed band, which you are doing here. Right? Next. So this is actually
pyramid sort of a thing. It is angular, it is little, right? Next. So this is no meaning at all. So this is actually a scatter plot where in 96,000 cases, more than 20. So there are many repetitions of the data are being seen. Next. So this is contour plots. So contour plots happens where? In most of the geological studies, tsunami data or geophysics data, right? So there you just do the contour plots. Next. So this is actually alpha transparent plotting. So it is exactly like a scatter plot, but with a circular aspect as the instead of dot, you're just going for this. Next. So this is jittering plot here. So there is a, helps to plot age times pregnancy, jitter age and jitter times pregnancy. So this is the jitter, this is the actual this. So there is some sort of a similarities in age under pregnancy of that particular data. Next. So two variables. So the bivariate, I said that here. So this is one variate and this is another variate. You can as well do it on the same scale and then have one normal here and then another normal here. So then you have bivariate normal. Yes. Next. So this is you said that here this is categorical aspect. So continuous and as well as the male, female are your age groups, right? Etc. Etc. You can as well take it. This as that here. Next. Yeah. So this is histograms with the same variable in the same bar. In the same bar, there are two types of this thing. So this is called as the cluster bar chart. So these two belongs to one cluster. This is another cluster, but it is within the bar the cluster. So which is dominant, you can as well know there. And then here also you can know that there which is dominant. This is more dominant than this. So when you just compare, this is reducing it and then this is increased. So that sort of a thing you can visualizations you can as well show. Right. Next. So this is actually more than two variables. So this is pairwise scatter plots are being taken. Whenever you deal with multivariate data, so you get all these scatter plots, you can as well have it in a matrix format. Next. So this is a cell type. Here also this thing here. So this is the diagonal. So density you can as well do that here. How the density is within the diagonal. So above diagonal it will be this similar. So the above diagonal is equivalent to symmetric to the below diagonal. That is how we can. Next. Yeah, so more than two variables is multivariate. So this is what actually you do. So this is mostly, what is that actually? Earthquake data. So what are the measurements you take it in earthquake data? No, Richter scale is the index. Longitude, latitude, depth. So these are the three variables which you use in earthquake data. Right? So whenever earthquake comes, what is the longitude? You note down. Then magnitude. Then the depth. How much of depth the earthquake has gone. So that is what actually is the multivariate data. It's a three variable case. Next. So this is for each variable. So it's just here. Depth group, and depth group. So this is longitude and latitude. Right? So if you just see here in this depth group, this thing is very less here, but this is quite heavy. So depth has gone very inside the earth. So that is what actually we can as well notice from this particular visualization. Next. So this is actually magnetic. All put together, you can as well study. So if you see that here, there is a similarity from this group to this group with regard to magnitude. So here it is also little 95% times it is similar, but here also it is the same, similar. So similarities at two different groups, two different earthquakes, you can as well plot it and then see that here how the pairwise comparison can be seen. Next. So how many dimensions are represented here? So all these things you can as well study by these days. So these are all available. So only thing is you should be clear in a particular package, whether it is a SPSS, Minitab, right, or Python, R. All these things gives you these visualizations. Next. Yeah. So what is missing is pie charts. I have not discussed, but I have told orally. So this is the three-dimensional plot. These things you can get it in Excel also, right? So most of you know this. Right? So this is the worst graphic in the world. So this you cannot really understand anything here. So even this type of a visualization one can as well do that here. It is not that good. So whenever you want to go for a comparison from country to country, then data is huge, it is big. Then under that particular context, you cannot have a simple visualization. So it will be a complicated, right? Your complicated transformation is being done here. So this may not really represent this thing here, right? So there are now till this particular slide, there are all visualizations which are discussed are very good. After those good visualizations, this is another bad. So anywhere, definitely there are certain things which are bad and most of the things are good in visualizations. Next. So this is a three-dimensional this thing. So this mostly we use in factor analysis. And then there you have 3 factors, 4 factors, or how many factors are influencing the data in reducing the dimensionalities. You can as well do that. Next. So this is the dimension reduction. So stepwise, then multi-dimensional scaling MDS. It is actually a multivariate statistical test. You may not know, you have to do PG for that, right? So these are the dimension reduction techniques where you can as well select the variable which is influencing all other variables, which is maximum. Like for example, you take it poll data, recent poll data in BRS, Congress, and this thing, and then see that here, what is a influencing thing. The people are doing it now, right? Which is influencing to win the election, before and after. So that sort of a comparisons can also be studied under the multivariate aspects. Next. So principal components, etc. So this you can as well see it in YouTube. You have various visualizations can be seen in this particular YouTube with this particular. So that is how you can as well study. So any questions? I have done my job. So if you have any questions, or you have any data set, you want to know that what sort of a study. See here, a statistician or a mathematician should be good enough when you just sees the data and say that, yes, this technique gives a better approach and a better insight to the data. So that is most essential under these particular aspects. So I'm thankful to the Vice Chancellor, Registrar, and Dean and Madam. I have done. So if you have any questions, you can as well ask me. Yeah.
So in the candidate pattern of that, the recent trend stock market, how far it is true that the same thing is going to repeat, or is the continuation of that one going to be reach some height? How far it is connected?
So definitely, if it is continuous or if it is the same, you should have the past data and the present data. The past and present data, if you see that here, if a particular share is repeating from past to the present, then you say that here whatever has happened last year, the same thing is happening. So for this, actually, this is a very good question which you have posed. For this, there is actually a technique called as, this is coming up. So this software is being developed in US. It is done through the formalization theory. So formalization theory, only in IIT Mumbai, people are doing it. But in India, it is not at come. Already, it's one of the father of this formalization theory is Tom Hales. He is from Pittsburgh University. Right? So most of the people now, they are doing it in OCaml. It's a language. OCaml is a language, and that OCaml is being used in formalization. So you are formalizing whatever question you have said that here. Last year, same share. This year, is it formalized into the same dip or same increase or decrease? So this is what actually is being done. So Thomas Hales, he is the father of this particular formalization theory, and IBM also is doing this particular formalization theory, so that Bayes theorem. So you just say that here, you just give the conditional probabilities and individual marginals, it calculates the Bayes directly. So you need not calculate everything and then see that here. So this is called as the formalization theory. So this is the latest technique with which people are using it. There is a company called Imandra, AIML company. So there, people are doing this sort of a thing. You sit in India, you can buy a share in Japan. So within minutes, how it is changing is being studied. Whatever question you have posed, the same thing they do it. It's a package. OCaml, they write it in OCaml. OCaml. And the guy who's very good in OCaml, and then he is doing a lot of business in India, he is from Chennai. Right? So Bharat or some name is there, his name. So that is what you can do that. So yeah. Yeah, if no questions, I thank you for the patient hearing. So, all the best. So, I mean, when I said that I said
that you should have more hands-on.
Computer science, maths, and statistics. All three hands-on should be there. Otherwise, your future is very bleak. I'm very curt in saying this because I've seen it. My hair is gray. So please listen and then have some sort of a hands-on. Take the same share market data for 30 days. You take newspaper, you take companies, Indian company, software companies, and try to analyze that data. Then you'll know what actually is happening. Thank you.
Thank you, sir. Another two. I request Dr. Sridevi Madam, HOD Department of Mathematics and Director SICA. Please felicitate our speaker, Professor V.V. Haragopal, sir, Professor of Statistics, Usmania University, Hyderabad.
Thank you, sir. Dr. Usha.
Please. The formal vote of thanks. Today's guest, our speaker, Professor V.V. Haragopal, sir, is a known person from Usmania University, Professor of Statistics. Not only Professor of Statistics and also in the data analytics, Sir is already Madam told in the earlier remarks. He's advisor for BSc Statistics course in our Dr. B.R. Ambedkar University. From 2019 to till date, his services is taken the university in the statistics department also. This today modeling and visualization topic, sir told the continuous and random discrete variable and other the scattered plot diagrams. All these, it will be useful for you in the future. Sir, I'm thankful to you for coming and giving good lecture to our students for on the occasion of Sri on the National Mathematics Day. And I'm thankful to Dr. Sridhar Madam, HOD Department of Mathematics and Director Sikha, conducted a good program on this occasion. I'm thankful to the Computer Center for organizing the YouTube link and another parts and also live Zoom link. And I'm thankful to the Chaitanya here coming for the same. I'm thankful to my colleagues supported me in this successful completion of this program. And also, my thankful to all the students who have supported me for this successful this seminar in Sri Ramanujan's Jayanti. And after this completion of program, I request all the students go to your concerned classes. Thank you. Thank you, one and all. So after lunch, you go to your class. Respective classes.